السلام عليكم.
وعليكم السلام.
ذاك اليوم ما اتفقنا أن يكون الجروبين مع بعض في من 8 أو 8 ونص شيء كذي. ما صار الاتفاق.
السكشن الثاني دكتور ما أكدوا يعني على
اوكي، هل في بإمكان انتم تجون بعدين؟ يس نو؟
ايه عادي.
البقية شلون؟
هو بتكون الساعة كم المحاضرة بعدين دكتور؟ لأن الساعة 11 عندنا كويز
يعني نخلص على 11 تقريبا مفترض، أو قبل شوية يعني.
مو مشكلة.
اوكي، في أحد عنده مشكلة من الجماعة الموجودين؟
أنا دكتور عندي محاضرة الساعة 9:30.
خلاص إذا نبدأ الحين. طيب. اوكي، تكلمنا في السامبلينج. أنا أحاول أختصر شلت بعض الأشياء. الشيء اللي المفروض ناخذه في ساعتين نحاول ناخذه في ساعة ونص أو أقل شوية، ساعة واحدة. في أشياء ما نقدر ندش فيها. anyway. المهم قلنا إحنا الحين هنا إذا بأخزن الداتا في الكمبيوتر، مهم جدا إن لما أحط الداتا as x of t أخزنها بسامبلينج rate بحيث إنه يكون شيء مناسب. فبعدين إذا الداتا في الكمبيوتر أنا بسترجعها باك نسوي reconstruction. أوكي، رحت from here. أوكي، رحت هني by sampling. الحين بسوي reconstruction، أبي أرجع باك بحيث إن هذه الداتا الموجودة فعلا يعطيني x of t. otherwise ما منه فايدة هالسامبلينج كله. Okay, and to reach this one وصلنا إلى شيء اسمه Nyquist criteria where f sampling لازم يكون greater than 2f max. اوكي، خذني مثال لكن ما في مانع نرد نكرر another one. So if we have this is my sampler and here I have x of t. Okay, important here to know s sampling rate. Okay, هذه مهم. And remember that this one is the train of impulses. Okay, so then in time domain, this is my output here. It is xs of t. So xs of t, it is equal to x of t multiplied by whatever we have from here, اللي كانت xp of t. Then working in frequency domain, then this is x of f equal to x of t, x of f, and we use convolution with xp of f. And xp of f is this one. Okay. طيب, suppose my x of t it is this. X of t is sinc square of alpha t, for example. Okay, now working in frequency domain, then sinc square that تشوفون في التable, then you will get in frequency domain it is this. Sorry, not here. This one. هذه sinc square. Okay, and هذه convolve with xp, and xp it is this. Okay, this is at 0, this is at fs, 2fs, minus fs, minus 2fs, and so on. What do we get here? اللي بحصل الآتي. This is f. So let me say that this is f max, and this is minus f max, and here we have alpha. Okay, first we'll get this one convolve with 0. And we know that convolution with a delta, I will get exactly the same. Okay, so f of t convolve with delta t minus t naught. In general, it is equal to f of t minus t naught. Okay, so then when t not equal to 0, then if t convolve with delta t, I will get f of t. So here f of or x of f, then I will get x of f, same as this one, same as the whatever we have here. So this is minus f max, and this is f max, and then this is my alpha, whatever we'll get here. Okay. طيب, convolution with f of s, then t f of t convolve with delta t minus t naught, I will get f of t minus t naught. Okay, so then here I will get exactly the same as f of t just shifted to t naught. اللي بيصير convolution with f of s, now with f of s, then I will get same thing just shifted to f of s. So I will get this. So the center will be at fs. So then from here to here it is f max. So then this is fs plus f max, and this is fs minus f max. By convolution with minus f max, same thing, just shifted here to minus f max. Okay, so similarly, convolution with 2f max, then I'll get same thing just shifted to 2f max, 2fs, and so on. But from here we said that this one, f of s minus f max, should be greater than f max, otherwise we'll get overlap. طلعنا Nyquist criteria, which is fs should be greater than 2f max. So then this is the case where fs greater than 2f max. Okay, so I will get this one. طيب, what will happen if I reduce F max? Fs, sorry. اللي بيصير الآتي. So if you reduce Fs, then this one will going to move because the Fs, instead to get it here, I will get it somewhere here. فاللي بيصير الآتي. Then this one will be here. It depends on F of Fs. Okay, if you reduce it, then you will get here. If you reduce it, then you will get here. If you reduce it, then there is a possibility to get touch. So this is the case here. Okay, similarly this. Okay, so then this is the case where if S exactly equal to, oops, to F max. Okay, ما في داعي نخليهم. So then this is 2fs. This is fs. Well, I will get another one here. Minus. طيب, case number 1 شفناها شلون بيكون distance between f max and fs minus f max. But now it's both, it's touch each other here. Okay, if you reduce it, إذا بعد قللناها, so what will happen if it is fs is less than 2f max? Then we'll get this situation. هذه will move here like this. Similarly, this one will going to move here, and this one will going to move here. Okay, and this one going to move here. Okay, طبعا هاي مواصل. Okay, now لاحظ اللي بيصير الآتي like this. So this is with positive sequence, positive slope, and this is with negative slope. So then I will get a straight line here. Okay, هذا البارت بيصير like this here. Okay, if you add these two together. What is my goal? My goal is to get back x of t. So then I'm going to connect a filter here, low pass filter. Then just we'll get y of t, and y of t should be equal to x of t. Okay, now here هذه عندي xs of f, so this is my xs of f. So in this case, can I put some filter somewhere to pass only the original one? The original one is this. the الأصل. Can I do something to pass only this? صعب. Because if you take filter, even though it is very sharp here, it means that you pass the original one plus this part, which is not equal to the original one. Okay, so then it is difficult to reconstruct. This one, it is very difficult to reconstruct because f of s is less than 2f max. Okay, what's about if it is equal? The kind of equal. So if it is equal, so then I will return back to this. Oops. Okay, I'm going to just a touch. Okay, similarly here. And here. Okay, now, can I design a filter only to pass original one, which is this? Yes, we can here, but see, I can just do this filter, digital filter to pass only this one. وهذه في الحقيقة expensive and it is impractical. So we don't have filter with vertical edge. ما عندي شيء كذي، ما عندي. Okay, become very expensive and practical. So then when fs equal to f max, then yeah, theoretically it is possible. Practically it's difficult. واضح? And if it is greater than, if it's greater than, then what do we get? This one we're going to move. Okay, and this one we're going to move. Similarly here. And here. Okay, now simple filter, you can put it here, okay, to pass only this one. So then here it is very easy to pass only x of f. So then if you have only, if you put a filter and you pass this one, only this one, and reject all the others, then in time domain, so this will be y of f, then y of t, it is sinc square. Okay, it is sinc square. واضح الفكرة. any question؟
واضح الفكرة.
اوكي خلينا ناخذ two examples, numerical example. Example. Suppose x of t equal to 10 cosine 2000 pi t. Okay, and it's sampled. And so we actually, so this is my x of t. And here we have sampling rate, f of s equal to 3 kilohertz. This is sampler. And then we take it to filter with cutoff frequency equal to 1.1 kilohertz. And this is my y of t. So let me see that whether with this fs and fc can we get original signal here. So it's mean that can we reconstruct it. So here we sample it, and here we reconstruct. And then so first we said that we are going to work with the time domain, so with the frequency domain. So then here we have x s of t. So x s of t is a convolution of x of t convolved with xp of t, and x s of f in a frequency domain is equal to x of f convolved with this real xp. So this is 0. So fs it is equal to 3 kilohertz. So this is 3, 6 minus 3 minus 6 and so on. Where f it is in kilohertz. Okay, what is x of f? So just we need to change this one from time domain to frequency domain. So frequency domain for cosine is half delta. So we have half delta. So this is f again in kilohertz. So here 10 divided by 2 it is equal to 5 and 5. And here f it is equal to 1001 kilo. So then this is will be equal to 1 and minus 1. اوكي فاذا بنوجد this نشيلها كلها. Take this one here. طيب, this is my x s of f equal to convolution of this two. What do we get? So this is f. So first convolution with a 0. So then I will get original one. The original one it is here and here. So this is at 1 and this is at -1. Okay, with a 5. طيب then convolution with a 3. With a 3, it means that move this one to 3. The middle will be at a 3 هذه. Move it to 3. Then this one will be at 1 plus a 3. So then it will be at 4. And this one will be at a 3 minus 1, which is 2. Okay, with a 6. So then this one will be at 6 plus 1, 7. And this one will be at 6 minus 1, which is 5. Okay, similarly with minus a 3. So this one will be equal to 1 minus a 3, which is minus 2. And this one will be minus a 3 minus 1 minus 4. طيب, with minus 6, then minus 6 plus 1 minus 5. And minus 6 minus 1 minus 7. And so on. Okay, now, my filter, it is the cutoff frequency for the filter, it is 1.1. Okay, 1.1, which is here. Okay, so then if I put a filter like this, then I am going to pass only this one. So then YF will be only this. This is 5, this is 5, this is Y of F, okay, at 1 and minus 1. So then this is Y of F, then Y of T, it is equal to 5 multiplied by 2, 10 cosine 2 pi multiplied by هذه طبعا كيلو هرتز. It will be 2 pi multiplied by 1000, okay, which is exactly equal to the original one. So then, since f of s greater than 2 multiplied by f max, so f of s greater than 2f max, okay, f max, it is clear that it is equal to 1, so which is greater than 2000, which is 2 kilo hertz, then yes, I can reconstruct it. Okay, so Fs, it is equal to 3 kilohertz, which is greater than 2. Okay, so then I can reconstruct it. Yeah, وهذه واضح جدا. Okay, so I get original one, so y of t equal to x of t. واضح. طيب. Now, if I change this one, Fs to 0.75. لازم كل شيء نسوي مرة ثانية. Okay. Now, if I change this one, fs to 0.75, what will happen? Kilohertz. I لازم نشيله now. Okay, now f of s, it is equal to 0.75. Anyway. Okay, now f of s it's equal to 0.75, and 0.75 kilohertz is less than 2f max, which is less than 2 kilohertz. So then for sure that it will be overlap. I cannot construct it, but let me see graphically what will happen. So now f of s equal to 0.75. So then this is my f in kilohertz. So then we have at 0, then at 0.75, 1.5, 2.25. Similarly here at 0.75, minus 1.5, and so on. And then نشوف الريزلت here. So this is F in kilohertz. طيب, with the 0 convolution, this one with the 0, then I will get same thing. So I will get at 1, 1 and minus 1. طيب. Now, convolution with 0.75. So we'll get, we move this one to 0.75. So then here will be equal 1.75. So I will get 1 here at 1.75. And another one, it is minus 1 plus 0.75, which is minus 0.25, which is this here. Minus 0.25. Okay, with the second one, with 1.5. With 1.5, down here it will be 1 plus 1.5, which is 2.5. So it will be long. 2.5, and another one is 1.5 minus 1, which is 0.5. 0.5, which is here. Okay, similarly with 2.25, so it is equal to 0.25 plus 1, so 3.25, and 2.25 minus 1, which is 1.25, and so on. Okay, similarly, here if you convolve with minus 0.75, so plus 1, it is equal to minus 0.125. Okay, so you will get here at 0.25 minus 0.75 plus 1 and minus 0.75 minus 1, which is at minus 1.75. Similarly, with minus 1.5 plus 1, it is equal to minus 0.5, which is here, and the other one will be equal to minus 2.5 minus. Okay, طبعا تكملة here. So if يعني my cutoff frequency at 1.1 kilohertz, it means that here. Okay, so if I pass all these, هذه طبعا XS of F. So what do we get? So here, as Y of F, this is F in kilohertz. I will get this too. So at 1 and minus 1. هذه أول شيء. Of course, this is equal to 5 and here 5. So then in time domain, y of t equal to, for this 2, 5 multiplied by 2, it is equal to 10 cosine. So f equal to 1000, so then 2 pi multiplied by 1000, so it is 2000 pi t. هذه أول شيء. Also, I will get this and this, which is at 0.5 and minus 0.5. So this 2, again, this is 5, this is 5. So then this is a plus 5, again 10, cosine 2 pi multiplied by 500, which is 1000 pi t. Also, we will get this. Again, 5, 5, this is at 0.25 and minus 0.25. So plus, and 2 multiplied by 5, 10 cosine 2 pi multiplied by 250, so it is 500 pi t. Okay, which is not equal to x of t. So y of t here, it's different. So if I reconstruct it, okay, then I will get something, I will get the original one, but with a distortion. Okay, عندي distortion, عندي harmonics. واضحة الفكرة؟ I hope it's clear. أحد يتكلم. Not okay.
واضح دكتور.
طيب. So let me take another example. Okay, suppose I have x of t here, and I have another signal. It's mixed together. Okay, where omega or x of t, it's less than 50 pi radian per second. And this is sinusoid, okay, with a with omega equal to 120 pi. An angle cosine 120 pi t. And it is k with large number. Okay, then the combination of these two, okay, which is x of t plus n of t, I take it to sampler. Okay, with f of s or omega s here, it's equal to 130 pi. Then let me say that here we have filter. And here we have y of t. What do we get? Okay, working with frequency domain. And the omega. So x of t, let me say that it is omega, it's less than 50 pi. So then the original one, let me say that we have it, it's from here to here, أي شكل يكون. Okay, so this is 50 pi and this is minus 50 pi. Okay, and here we have k cosine 120 pi. So 120 pi, it's so it's one here. Another one here. Okay, هذه noise, okay, مثلا أو distortion. I don't want it. I don't want to store this one. I want to store x of t, and when I reconstruct it, I want to get here x of t, not x of t with a distortion. So if you sample it with omega s 130 pi, شو اللي بحصله الحين؟ أخذناها. If we sample this one at 130 pi, then I will get this. أحاول اللي بيصير. I will get the original one, 50 pi minus 50 pi, and this is at 120 pi. This is minus 120 pi. Okay, then it's we convolve this one as we say that it is with a 0, then with 130 pi, then to 60 pi, and so on. Okay, so convolution with a 0, I will get this. Okay, with 130 pi, what do we get? So move this one to 130, so then I will get here. I will get something here. But say 50 plus 130, so it is 180. So here it will be at 180 pi. And this one, 130 minus 50, كم بتكون؟ Oops. ما نقدر نحي هذه. لازم نسوي كذي like this. هذا. دقيقة بس ببندر وارجع لكم بعد دقيقة. كل اللي سويناه ما تمحى. Anyway. Okay, again. على السريع. Okay, as we said that here, we have x of t, okay, with omega less than 50 pi radian per second. And here we have distortion n of t equal to k cosine 120 pi t. Then this one, I sample it at omega s, which is equal to 130 pi radian per second. Then I filter it to get y of t. Okay, addition of this two here, which is x of t plus n of t, it is this one. Something like this. So this is at 50 pi, and this is at minus 50 pi. And this one I will get at 120 pi and minus 120 pi. Now we convolve with xp of f or omega, omega. So it is 130. So then we have at 0, then at 130 pi, 260 pi, minus 130 pi, minus 160 pi, and so on. So what do we get here? So this is omega. I will get the original one. هذه خليها 0, so I will get this 50 pi, and here 120, and minus 120. Okay, add the convolution with 0, convolution with 130. So then this one we're going to move 120 to 130, so it is 220, 250. بتكون هنا at 250. Okay, this one will be minus 120 plus 130, which is equal to 10. 10 will be here. Okay, this one will be at minus 50 plus 130. It is 80. So 80 will be here. And 130 plus 50, it is 180. So 180 will be here. Okay, this is with 130. Similarly, with minus 130, then minus 130 minus 120, we'll get here at minus 250 pi. Okay, minus 50 minus 130, it is minus 180. And 50 minus 130, it is equal to 80. It is here. And 120 minus 130, it is minus 10, so which is here. And so on. Now this is my x, s of f, which is here. Now, if I take a filter, okay, so if I put it here, this is my filter, for example, then I am going to pass this one, which is x of t, but the plus this 2. The distortion, then it is included with a distortion. If I decrease it again, هذه بيكون at 10. Okay, at 10 pi, and this is at minus 10 pi. So always we're going to have distortion with the original one. وهذه مو بالجول مالتي. I don't want to store distortion on n of t. So what to do? If we can, if decrease this one by 10,000, by 1 million times, okay? Multiplied by some factor, for example, some constant at 120 and minus 120, what will happen? So then the height of this one will going to decrease, okay, to something like this. So then all these, when you sample it, then you will get something very small here. So you have it. You will have it, but with a height very small. Similarly for all these. And here as well. That. Astaghfirullah. Okay. Okay, so down here also, we have very small, the height of this one, very small, so it comes. Similarly here. Now with this filter now, I'm going to pass the original, but with this one, but distortion is very small. Okay, that we can neglect it. Okay, so it means that y of t will be equal to the original. Okay, how to do this one? I need a filter here. I need to put a filter. Another filter. Okay, to pass x of t here plus n of t, but divided by some values. Say, for example, I want to reduce it to by 1,000, by 10,000, by 1,000,000. Okay, how to do this? This filter is very simple filter. It is low pass filter. هذا الفلتر simple filter, which is this one. Okay, I'm going to pass x of t, n of t here. Down here, I will get x of t plus n of t divided by 1,000. Okay, so just I need to adjust R and C to get this 1,000 here. How to do this one? I need to find h of omega for this one. Okay, and what is h of omega? Frequency response. So then I need to work in frequency response for this. This is equal to R, while this one it is equal to 1 over j omega c. Okay, فهذا الفلتر it is very cheap filter. So R and C. طيب, what is h of omega for this one? The voltage here, so it is 1 over j omega c divided by R plus 1 over j omega c. So then it is equal to, if I multiply by j omega c, so here we have 1, and here 1 plus j omega, right? والله صار هذا الوايت بورد ممل. Okay. So we said that here we multiplied by j omega c. So here we have 1. Here we have 1 plus j omega rc. Okay, what is the magnitude of this one? هذه important. So magnitude of h of omega equal to here 1 plus omega rc all square under root. Okay. شلاب بي أنا الحين what I want exactly, I want at omega equal to 120 pi, reduce the k, this k by 1000. So reduce by 1000, then the gain should be equal to 1 over 1000. So then the magnitude here at omega equal to 120 pi radian per second, magnitude equal to 1 over 1000. So بالتالي بيكون it is 1 over 1000 equal to 1 over 1 plus this is 120 pi RC. So then from here, so root of 1 plus 120 pi RC all square, equal to 1000. If you square both sides, so then this becomes a square, and you can remove this root. Okay, and take -1 here. Okay, then take root both sides. So this is the root here. So cancel this one. Divided by omega, which is 120 pi. So then here you will get RC. So RC equal to this one. And then the value here. This is RC. That is equal to 2.6 second. Yeah, RC, we know that it is equal to tau in circuit 2, so it is tau. So then, for example, if you choose this one as equal to 10 kilo ohm, then C will be equal to 2.653 divided by 10K. So it is equal to, I need to calculate it here, it is equal to 0.2 milli, so it is 265.3 microfarad. Okay. So this is the value of C. أي سؤال, any question?
شكرا دكتور يعطيك العافية.
Okay, so then this is the frequency response. هذه الفريكونسي response H of omega, and we know هاي كان سؤال أيضا موجود في الاختبار شيء من هالقبيل. So express this one an input-output differential equation. Okay, also you should know from here how to find the H of t. وهذه بعد كان سؤال موجود في الاختبار impulse response. فإذا في عادة أنا أحتاج ال X of t, just I need a sampler, but sometimes إذا في distortion or no noise with high amplitude, then I need to put a filter here. الفلتر هذه الغرض ماله is to reduce the weight of the noise, but this filter is reconstruction filter. تمام؟ نكمل الصورة إذا اشتغل معانا دقيقة. Okay, هذه complete picture for sampling. So هذه اللي عندي x of t plus n of t. So then here we need anti-aliasing اللي هي RC, it's very cheap filter. Then we sample it, okay, at f of s greater than 2f max. I will get xs of t. Then I need analog to digital because we want to store digital 10010, so we change it to analog, from analog to digital. Okay, so we store it. But then if you want to return it back, so you need digital to analog, so from 100 to analog number. Down here we need low pass filter, we call it is reconstruction filter. So then we will get y of t. If fs greater than 2f max, then y of t equal to x of t. Okay, بشرط ان الفلتر يكون هذه filter it's reduce noise or n of t or distortion. أي سؤال, any question? اوكي, قبل ما تمشون بس بقول لكم شيء عن حق الفاينل. باكر عندنا الكويز, لا تنسون ها, الكويز الساعة 4. بس حق الفاينل يعني من الأسئلة اللي ممكن يعني أو طريقة من طرق الأسئلة. So this is my x of t, here t, that we say that I have this. Okay, so here 3, this is 7. Okay, هذه طبعا واضحة. it is u, يعني ممكن تنكتب it is 7u minus 7 over 3 r of t. Okay, so plus 7 over 3 r of t minus 3. خلينا نقول هذه, you have this. Okay, and the question find, this is x of t, find x of t at t equal to 2.25 second. How to solve it الحين ما يبي drawing، ما يبي أي شيء آخر، يبي find x of t at t equal to 2.5. يعني في النهاية هذه أنت فقط الجواب اللي تحطه، الجواب النهائي، كل الخطوات الأشياء اللي تسويها هذه بالنسبة لي أنا بعدين وقت اللي أصحح ما منه فايدة. أهم شيء اللي بتحطه لي في هذا المربع. Okay, so how to solve it? How to find this t? So if you plot this one, so you will get this. Okay, just write the equation. هذه سهلة لكن فيها خطوات يعني ترسمها. So then x of t equal to, it is start at 7. Okay, slope line, it is equal to 7/3 multiplied by t. So now x at 2.25, it is equal to 7 minus 7/3 multiplied by 2.25. So if you calculate it, it becomes 1.75. So then here just you need to put 1.75 and correct to 4 decimal place is this one. الحين نشوف يعني معناته كل الأشياء هذه for yourself. اوكي، هذه اللي انا يا احط لك صح يا احط لك غلط. اوكي، ناخذ another example. Suppose x of t equal to e to the power of minus t. The question is find x of f magnitude, okay, at f equal to 2 hertz. So how to find it? معناته بعد في النهاية just I want this, I want a number to put it here, number, numerical number, not equation. Okay, اللي لازم تسويه الآتي. So just find from here, find x of f or x of omega, whatever. هذه from the table, it is equal to 2a, a equal to 1, so then it is 2. Divided by omega square plus a square, which is equal to 1. Okay, so then if f equal to 2 hertz, then x of 2 hertz equal to 2 over the 2 pi multiplied by 2 all square plus 1. And if you calculate this one, it becomes 0.0126. So then put the number here, 0.0126. فبعد من هذه يا صح يا خطأ. يعني شبيهة بطريقة الكويز اللي قاعدين نسويه الاساينمنت كويز. So you put the final number here. Okay, الكود هذه مالي شغل فيه أنا علي من النمبر هذه. So either it's correct or no. أي سؤال؟
واضح دكتور.
اوكي. فالمهم القصد إن لو شفتوا في الفاينل شيء من هالقبيل لا حد يقول والله ما تدربنا ما تعلمنا ما عرفنا، فالحين أنا قاعد أشرح لك. أنت مهمتك الحين تقول ما فهمت هذه. أوكي، فهذه المهم آخر لكتشر، أتمنى لكم التوفيق والدرجات الزينة في الفاينل وجود جريد سواء كان في هالمادة أو في بقية المواد، والله ييسر لكم وتخرجون يعني مهندسين تخدمون بلدكم. أحد عنده أي شيء؟
يعطيك العافية على طول الكورس، رحم الله والديك.
الله يوفقكم إن شاء الله. إذا أحد عنده أي سؤال أي استفسار فممكن يعني بعض الأحيان أكون موجود في الأوفيس أور، بس الأسبوع القادم بيكون أصلا الفاينل، فيطرش لي على الشات إن عندي سؤال، أو إذا شافني أونلاين يتصل إذا كان وقت مناسب بجاوبه، إذا ما كان مناسب بجاوبه بقول له مثلا أنت واعد على وقت آخر. الله ييسر أموركم إن شاء الله. السلام عليكم، فما الله.
يا معلم.
السلام.